In this video, Algebra 1, we're going to be going back through the properties of exponents and how to simplify exponents. First of all, exponents are a shorthand way of writing multiplication. They quickly allow us to show repeated multiplication. So parts of an exponential expression are, so here we have this, and this is read 6 to the third power, or 6 cubed. So first of all, we have the base. The base is 6. The 3 up top is the exponent, and 216 is the evaluation. So truly the whole thing is called 6 to the third power. So the base, the exponent, and the evaluation of the expression. So let's take a look at these powers of 2. So remember, exponentiation is just a shorthand way of writing multiplication. So let's just be reminded of what these particular powers of 2 mean. So remember, 2 to the fourth means 2 times 2 times 2 times 2. And if you want to think of that as simply 4 times 4, we get 16. 2 to the third, 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 2 squared. And then 2 one time. So look at what's happening here. 2 to the fourth is 16. 2 to the third is 8. 2 to the fourth is 4. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. Therefore, 2 divided by 2 would be 1 if we continue the pattern here. And that is correct. 2 to the 0 is 1. And we can make a first generalization here, is that any base to the 0 power is 1. Any base to the 0 power is 1. It works every time in every sequence of powers. 16 divided by 8 is, or 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2. 2 to the negative 1 power is 1/2. So if you think about it in terms of comparison here, if we compare 2 to the positive 1 and 2 to the negative 1, they are related. So 2 and 1/2, they are reciprocals. Therefore, 2 to the positive 2 and 2 to the negative 2 must also be reciprocals, which is what happens if we take 1/2 and we divide it by 2. If we divide 1/2 by 2, we get 1/2 of a half, which is 1/4. So 2 squared is 4. 2 to the negative 2 is 1/4. If 2 to the third is 8, then 2 to the negative third will be its reciprocal, 1/8. So we can make another generalization here. Negative exponents make reciprocals. They don't make negative numbers. They make reciprocals. Negative exponents make reciprocals. So, two great generalizations. Any base to the 0 power is 1, and negative exponents make reciprocals, not negative number. Notice all of these powers of 2 are all positive. Positive 16, positive 8, positive 4, positive 2, positive 1. 2 to the negative 1/2 power is positive 1/2. 2 to the negative 2 is positive 1/4. 2 to the negative third, positive 1/8. Negative exponents make reciprocals, not negative numbers. So those are just a few of the powers of 2. So let's use what we just looked at and let's evaluate 0 and negative exponents. So here, we're not solving because these are not equations, but we will be simplifying these expressions based on the generalizations that we just made. So let's get started here, and we'll do this first column. So first of all, if we have 4 to the negative third, remember, we don't get a negative number here. Negative exponents will make reciprocals, so that means that 4 to the negative third must be the reciprocal of 4 to the third, so 1 over 4 to the third. 1 over 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. 1 over 64. So 4 to the negative third is 1 over 64. Next, 7 to the 0. Our first generalization was that any base to the 0 power is 1. So 7 to the 0 power is 1. Nothing to calculate there, nothing to do, it's simply just 1. Next, another negative exponent. Remembering that negative exponents make reciprocals. Now notice that this is negative 5 in parentheses to the negative third power. So we're going to take the reciprocal of it, and it will be 1 over negative 5 in parentheses to the positive third power. So when we work this out, it will be negative 5 times negative 5 times negative 5. So what do we have on the bottom here? We have 1 over negative 5 times negative 5 is 25, and 25 times negative 5 is negative 125. Now this base started out negative, and that negative base was raised to an odd power, and it will remain negative because there are an odd number of negative signs. Next, number 4. Number 4 is super, super tricky. So I'm going to put some stars around it because this is one to keep in mind. If you see the negative that is in front of that 5, what it really means is this, and we would even read this as the opposite of 5 squared. So because of order of operations, if we follow order of operations, we will square first and then we will take the opposite. So when you have the opposite of 5 squared, it is as if you have negative 1 times 5 squared because there are no parentheses right here. So if we follow order of operations, it will be negative 1 times 25, and that will be negative 25. Notice, no parentheses here, no parentheses whatsoever. It's going to stay negative. So that is 1 through 4. Let's take a look at 5, 6, 7, and 8, and we'll continue to use the generalizations that we made on the previous page. And actually, let me slide this back over because I want us to compare 4 with 5. In number 4, there are no parentheses, but in number 5, there are. And in number 5, if we have negative 5, not the opposite of 5 squared, but negative 5, the quantity squared, it truly does mean negative 5 times negative 5. And when we multiply negative 5 times negative 5, we do indeed get positive 25. So that's a difference there, just to bring that to your attention. Number 6. Number 6 is 3 times a to the negative 2. And number 6, 3 is to the first power, and only the first power. Only the a is under the power of the negative 2. And if negative exponents make reciprocals, what we really have here is 3 times 1 over a squared. Negative exponents make reciprocals. And once again, that exponent is only on the base of a. So 3 times 1 over a squared is 3 over a squared. We'll compare that to number 7. And in number 7, the 3a is in the parentheses. And now the negative 2 has power over everything inside of the parentheses. So what this really means is 3 to the negative 2 as well as a to the negative 2. And if both of those bases are to the negative 2 power, then we will take the reciprocal of both of them. 1 over 3 squared, a squared, which will be 1 over 9a squared. The difference is 6 does not have parentheses, 7 does. Number 8, down at the bottom, again, parentheses, and everything inside of the parentheses is getting raised to the negative 2 power. So this is testing your review from pre-algebra right here, properties of exponents. So everything is getting raised to this negative 2 power, so 10 to the negative 2 times x. So if you recall, and we will be hitting it in our next video, but this is a power raised to a power. We actually multiply those exponents together there. So here we've got 10 to the negative 2, which we will take the reciprocal of because that's what negative exponents do, and get our answer here of x to the 6th over 10 squared, which is 100. That's number 8. And then we've got one more sneaky little problem right over here, and I think I can fit it right on the paper. This is a fraction being raised to a negative exponent, and a fraction raised to a negative exponent. Since negative exponents remind us to flip that fraction because we get a reciprocal, well, how about we flip the whole thing? And then that negative exponent will become positive 3. Why? Because negative exponents make reciprocals. And that's what we just did. We just flipped this whole fraction, and then the exponent becomes positive. And now we can simply evaluate. Remember, everything inside the parentheses is getting raised to the 3rd power. 5 to the 3rd, y to the 3rd, 3 to the 3rd, x to the 3rd. This will simplify. 5 to the 3rd is 125. Y to the 3rd. Once again, the variables are always the easiest part. 3 to the 3rd is 27, and then x to the 3rd. So there's your simplified answer. And yes, we will be practicing a lot of these in class and on IXL.